Okay, good afternoon, all. Okay, sorry for the starting late due to some network issues. I was not able to connect. Okay, in last lecture we have discussed related to the lead tin alloys, the nickel alloy, and babbits, that is the white metal alloy, and we have discussed in brief related to their composition properties and applications, along with some microstructures. We have completed that part. Now, in this non-ferrous alloys, the last part is related to the composite materials and nanomaterials. These are uh, means you can say that lots of research is going on this composite material and nanomaterial. These are the futuristic materials which are going to be used in the futures for different applications, because they are having their unique properties. Okay, now we will start with the composite material. Now you can refer this slide. What is the first we will see the what is the meaning of the composite material, then we will go in the discussion related to the what are the different types of the composite materials, and after that we will see the applications of the composite materials. Okay, uh, only one lecture is allotted for this composite material and nano material. Means they are not going to ask you in brief, just they are expecting that just you should get aware related to the what is the introductory part of these materials, what are their properties, general properties, and you can say that their general applications. And if you are interested to continue your project work, and these composite materials or nanomaterials are having wide scope, you can complete your BE project also. And if you are looking for the higher studies, then it will be very good for completing your project. For as far as your post graduation research work is also concerned, you can do the research work on this composite materials and these nano materials. Now we will discuss one by one what is the composite material. Now, composite material, as here I have taken some points. Composite material is made up of two or more materials. Okay, here it will be combination of minimum two materials will be there, two different materials having different physical and chemical properties. Two or more you can take, minimum two should be there, minimum two materials, and more than two can also be considered, having different physical and chemical properties, and they will be combined to form a material, a new material you can say that, and that material will be composite material, and it will be having different properties than its parent materials. Okay, it will show the different physical properties, different chemical properties, or different mechanical properties will be there. But here what will be the difference, you will be able to separately identify in the finished product. If that finished product you have manufactured with two or different materials, then in that finished product also you will be able to identify your parent materials. Okay, parent material can be identified in the finished products also. That will be termed as the composite material. Then there are depending on their nature of the existence, these composite materials are classified in two types. That is a naturally existing composite material, which are in the existence by the nature, that will be, or they are in the naturally existing materials, that will be termed as the natural composites. In that you can take the example of the wood. Then bamboo is considered as the example of the natural composite. Then um, body bones, these are also considered as the natural composites. Now, wood and bamboo will be composite material of composite material, or its elements will be two elements will be there, that will be cellulose and lignin. And for bone, it also consists of two materials or two basic elements, that will be collagen and apatite. Okay, in this way these are naturally existing composites, that's why these are termed as natural composites. Then man-made composites are also there. Now, widely used man-made composites is the concrete. Okay, concrete or FRP means fiber reinforced plastics, and fiberglasses are there. The widely used man-made composite is the concrete. Concrete, it will be the mixture of you can say that sand, then loose stones, and cements. Okay, that will be the man-made composite, and that is you are aware of, and you have, I think you have watched it very, means it is very familiar to you. That is the concrete which is used in the construction work. Okay, that is the man-made composite. And which are the in the natural existence, naturally existing materials like wood, then bamboo, then bones. These are all natural composites. Okay, this is the classification of the composite material depending on the their nature of the existence. Now the next is the classification of the composite materials depending on the, what you can say, the distribution of the whichever. Now this, first I will tell you that the composite material, it will consist of one matrix. Okay, two elements will be there, minimum two elements, and from that minimum two elements, one element will act as the matrix. Okay, it will be termed as the matrix, which will act as a binder, means which will help in the keeping the other material intact. Okay, other material intact, that will be termed as the matrix. And the material which that matrix is keeping intact or binding together, that will be termed as the reinforcement. Okay, that may be termed as the reinforcement. Now the composite materials are classified in different ways depending on the distribution, whichever distribution is there in the, means you can say that matrix and reinforcement. Depending on the nature of this distribution, three types will be there: fiber reinforced materials, laminated materials, and dispersed materials. We will see one by one. First will be the fiber reinforced plastics. Okay, in the fiber reinforced plastic, before this I will show you the diagram. So these are the three types. Okay, this is the fiber reinforced composites, fiber reinforced composites diagram. Then this is the laminated composite, and this is the particulate composite or dispersed composite. Okay, particulate or dispersed composite, laminated composite, and fiber reinforced composite. You can refer these diagrams. I will explain one by one. I will explain first this fiber reinforced plastic. Now here, this fiber reinforced plastic, in this fiber reinforced materials, what you can say that here, the fiber shaped materials will be there. It will be having high strength. Okay, fiber shaped material, it will be having high strength, and these fibers are introduced in the soft material. Okay, whichever remaining material is there, that will be termed as the matrix. In this soft matrix, soft malleable matrix, fibers which are having high strength or high hardness, that will be introduced in that matrix. Okay, these are the fibers, and it will be introduced in the soft or malleable material, or you can say that soft malleable materials matrix. And these are the fiber shaped particles will be introduced. That's why this material is termed as fiber reinforced composite. Okay, now here this matrix material will be soft and malleable in nature. This matrix material, okay, this matrix material will be soft, malleable in nature, and whichever fibers we have introduced here, the, these will be having high strength, high hardness. Now resultant material, whichever this resultant material formed by combination of these, will be termed as fiber reinforced composites. And now here what will happen, whichever load will be applied on this material, that load will be taken on this fiber. Okay, they will provide you very high strength. Okay, means this matrix material will take the load and it will transfer that load to these fibers, and it will get distributed in this, it will get distributed in this way. It will provide you high strength, high hardness. Then due to this fiber materials, that will also provide you better corrosion resistance, better oxidation resistance, and better electrical and thermal conductivity. So these will come in the properties. What are the properties will be here? These material will be having very high stiffness, high strength, high hardness, then high toughness will also be there. Then due to this combination of the fiber and that matrix, here fiber will be having high strength and this matrix will be soft and malleable. Due to the combination of these two, that resultant material which will be formed, it will be termed as fiber reinforced composite, and it will show you high stiffness, high strength, then high toughness. Along with that, it will provide you better corrosion resistance, better oxidation resistance, and better thermal and electrical conductivity. Okay, now here we have to learn related to the nature of these fibers, fiber particles and these matrix particles. Now these fiber particles and these matrix particles, they may be metallic in nature or they may be non-metallic in nature. Okay, both this matrix as well as which fibers you are introducing here, they may be metallic or non-metallic. Now, if suppose first we will discuss related to the fibers. Now, if fibers are metallic in nature, then you can use maybe it may be boron, it may be you can say that tungsten, then stainless steel or simply steel, then beryllium or molybdenum. These types of the metal fibers can be used. Or sometimes you can go for the non-metal fibers. Non-metal fibers will be like, for example, you can say that carbon, then glass, then you can say that alumina, then silica. These are the different non-metallic fibers also you can use. Okay, fibers may be metallic in nature or non-metallic in nature. Metallic fibers, for example, boron, tungsten, steel, stainless steels, these can be used. And the non-metallic fibers like carbon, glass, alumina, silica materials you can use, or you can also use the silicon carbide or boron carbides. These can be used as the fiber materials. Now related to this matrix material, okay, matrix material, it will bind these fibers. Okay, matrix material which will be the binding force which will be provided, required, that will be provided by that matrix material. Now here matrix material also maybe it may be metallic or it may be non-metallic. Now for some examples of the metallic matrix materials are your elements like copper, aluminium, then nickel, titanium, and you can use their respective alloys also. Aluminium alloys, copper alloys, nickel alloys, titanium alloys, these can be used as the metallic matrix. Now in terms of the non-metallic matrix, you can go for the non-metallic matrix like polysters, or different types of the resins are there. Epoxy resins, you can use different types of the resins or polysters. Okay, it will come in the different types of the polymers. In short, you can say that different kinds of the polymers can be used as the matrix materials. So this is the related to the their composition parts, means the fiber and the fiber material or that matrix material, it may be metallic or it may be non-metallic in nature. And according to that, some metallic fiber materials like boron, then molybdenum, tungsten or steel, stainless steels, then non-metallic fibers like carbon, glass you can use. Then for the matrix, metallic matrix like aluminium, copper, then their different alloys, then nickel, their alloys you can also use. And in non-metallic matrix, you can use different types of the polymers. You can say that different types of the polysters or different types of the epoxy resins are there that can be used there. So, and after this, studying this related to the their composition, then different properties, we will move towards their specific applications for this fiber reinforced composites. Here I have highlighted some applications. Okay. This part I have already discussed with you. Okay, fibers will be providing high strength materials in the soft ductile matrix. Okay, then strength will get improved due to addition of this high strength fibers. Then matrix fibers may be metallic or non-metallic in nature. Then common metallic fibers will be like boron, beryllium, steel, stainless steel, tungsten, molybdenum. Then common non-metallic fibers can be used like carbon, glass. Then metallic matrix which are having means ferrous nature, or you can say that sorry, not ferrous nature. Here metallic and non-metallic, here we are going to differentiate in the form of metallic and not metallic. In metallic you can use aluminum, copper, titanium, nickel and their alloys. And in non-metallics, different types of the polymers, simply different kinds of the polymers like polysters, different types of the epoxy resins can be used here. Now these are the different applications. Okay, at the bottom here, this part also I have discussed already. These are properties of fibers reinforced composite materials. Now some applications are there. Some fiber reinforced materials, these are used for manufacturing of the vehicle tires. Okay, different vehicle tires are manufactured with the help of this fibers reinforced materials only. And how these are manufactured? In the nylon material, in the nylon material, steel fibers are introduced. Okay, in the nylon, it will be termed in the, or it will be classified as polymer. In this polymer material, you can introduce the steel fiber. Okay, steel fibers are added in nylon, and from that, this vehicle tires are manufactured. Then manufacturing of the different aircraft parts, it can be done by introducing boron, boron fibers in the aluminum material, okay, or in the aluminum matrix. Then these composites are used for aircraft parts. Then fiber reinforced plastics are also, means you can use carbon can be introduced in the plastics. Okay, carbon can be introduced in the plastics, and that can be used in the manufacturing of the different aircraft parts. Then RCC, okay, RCC is there, reinforced cement concrete. It will be reinforced cement concrete. What here, this combination will be like this: steel rods in your concrete. Already that concrete is also a composite, but in that concrete we are adding the steel rods. Steel rods, which that concrete, it will be termed as RCC, reinforced cement concrete. Then fiberglass composite materials are there. These are used for manufacturing of helmets, cars, then different jeep bodies or scooter bodies. So these are the different applications of fiber reinforced materials. This is the first type of the composite material. Then after this, laminated materials will be there. Okay, laminated materials will be there. Okay, you can refer this second diagram. These are the laminated materials. Now laminated materials here, laminated materials consists of two or more layers of different components. Okay, different components, two or more layers will be added. Okay, this is your matrix material, and two or more layers will be added. This is shown by this white colors. Okay, now here you can take the example of laminated plywood, then aluminum alloy. You can say that copper clad stainless steel, then aluminum alloys, aluminum alloys. In that aluminum alloys will be there, and one pure aluminum layer will be given. Pure aluminum layer will be provided. Then different types of the copper clad stainless steel. Stainless steel material will be there, total stainless steel material, and in that stainless steel material, few layers of the copper will be given. Alternate layers, you will be able to see the alternate layers. Okay, or in the nickel, you can give the you can say that in the stainless steel you can give the alternate layers of the coppers, or sometimes alternate layers of the nickels. In stainless steel material, alternate layer of copper, or you can say that bimetallic strip of the copper and steel, then bimetallic strip of copper and nickel can be used. And all these are used, these laminated. Okay, these laminated composites, these can be used in to control the temperatures in the ovens and furnaces. Okay, this is the application. These can be used in the controlling the temperatures. You can control the temperatures in the ovens and furnaces. Here I have highlighted that, means it will be thermostatic controls consisting of bimetallic strips of copper nickel. It is used to control the temperatures in the ovens and furnaces. And these laminated composites that can be extensively also used in the aerospace, or you can say that in the aircraft industry it can be used. These are the some examples. which already I have discussed. That's laminated plywood, then aluminum clad aluminum alloy, then copper clad stainless steel, then titanium clad steel. Titanium clad means here on the steel material you are providing the titanium layers. Here on plywood material it will get laminated with the help of some metal strips. You can use different metal strips. Okay, this will be termed as the laminated material. Then it will provide you very good strength, very good stiffness, and its coefficient of thermal expansion will be very less coefficient of thermal expansion. That will be the properties. Means it does not changes its dimension as there is a rise in the temperature. Means very good coefficient of thermal expansion is there. That's why due to these properties it is used to control the temperatures in the ovens and furnaces. Then it can be also used in the aerospace industry, or simply you can write the aircraft industry. Lots of composite materials, these are largely used in the aircraft industry because they will provide you, means their they will provide you the desired strength with the very much lesser weight as compared to the other materials. Okay, then after this laminated materials, the third type is the dispersed materials. Okay, third type will be dispersed materials. Now in this dispersed materials you can say that the particles of the one metal or one material are distributed in the second material. Okay, and it will be distributed as a mechanical mixture into the base material. Base material means the another material. Particles will get distributed in the another material. The particles material will be termed as the particulate. Okay, whose particles we are distributing, that will be termed as particulate, and in which material we are introducing that material will be termed as the base material. Okay, here it is explained in the another way, that is in a particulate composite is characterized as being composed of particles suspended in the matrix. Here matrix is nothing but your base material and the particles of the particles, that is termed as the dispersion material. That particles we are going to distribute in it. Now whichever particles we are distributing, it may be of any kind of the shape. It may be circular, it may be, means it may be a irregular shape or a regular size. uh, that will be termed as the dispersed material. And example of it, you can say that the concrete. In the concrete, you can say that we are taking the sand. That sand will act as the base element. And particulate composite means the dispersion material will be, you can say that the stones or some cement particles, that will be termed as the dispersion elements. Okay, some other examples highlighted here: sintered aluminum powder, then thoriated tungsten, then thoria dispersed nickel. These are some examples of the dispersed materials. Now dispersed materials, its diagram will be like this: dispersed materials or particulate composites, these are the dispersed elements. Okay, particles will get distributed in the this matrix or the base element or base material we are introducing the particles of the another element, that will be termed as particulate. This will be your particulate or dispersion material, and this is the base material or the matrix. Okay, in this way particles will get distributed. Now here some applications are there. It can be used. Now here properties will be, it will provide you high strength, high creep resistance, and these can be used at the higher temperature ranges. Okay, higher temperature ranges. Now these can be used for manufacturing of different components, different appliances which we are using in our day-to-day life. Then different types of the cutting tools. All these components are manufactured with the help of this dispersed materials or dispersed composites. Okay, so these are the different types of the composite materials, their different compositions, their properties, their applications. Now after this, the last point from this chapter is the nano material. Now These are the nanomaterials. These are the some introductory sentences for that. Here I have taken this nanomaterials. This will be the introduction, then some properties will be there. It will be having excellent mechanical, optical or electrical properties. In short, what are the nanomaterials? Now the nanomaterials, these are the materials which are having, if you take its single unit, if you take its single or smallest unit, that smallest unit size, it will be in the range of 1 nanometer to 100 nanometer. It's, if you consider its smallest size or single unit, and that single unit, if you measured its size, then it will lie in the range of 1 to 100 nanometer, means very small size particles or units will be there. That's why it is termed as the nanomaterial. Okay, these are the nanomaterials. And the technology or the science which we is dealing with this research related to this nanomaterials, it will be, that technology will be termed as the nanotechnology. Okay, and in this nanotechnology, the we are studying related to the how to do their synthesis, how to do their fabrication work. All these work is going on. These are recently developing materials, means this technology in is these nanomaterials are in its initial phase now. Okay, this, lots of chances or lots of scope will be there for their modification or their research work is there. Now these nanomaterials will be having, as their particle size is very small, they will provide you excellent tensile strength. Means tensile strength, hardness related properties will be very good. That is the mechanical properties. Then there are optical and electrical properties. In this sense, their thermal conductivity, you can say that that properties will be very good. Then some applications, lots of applications are there. Application part is very important in this. So I have collected some diagrams. These are the some different nanomaterials which are in, which are in the used in the practical life. These are the nanomaterials having spear like shape, nanospheres. Okay, nanospheres, you can say that different nano, three or some three or four nanospheres I have highlighted here. But these are, the first is the solid in nature. Now the second is the polymeric hydrogel. Okay, nanosphere with polymeric hydrogel, and nanosphere with mesosporous silica. Mesosporous silica particles will be there. Okay, the on the surface, some mesoporous, or you can say that porous silica particles will be there. Then it is some tube shaped, nano tube shaped materials are there. It can be termed as the nanorods, the nano capsules. And then different types are there. Okay, self assembled NP is there, nanoparticles, self assembled nanoparticles. Then these are different types, self assembled nanoparticles. Okay, then these are the nano shells, different nano shells are there. Okay, so these are the different kinds of the nanoparticles or different types which are in the use. Now we will see the their applications. Now nanomaterials, these are used in the different, means there are different products can be manufactured with the help of these nanomaterials. And that products may be like, you can say that different kinds of the paints, insulation materials, different lubricants or different added use, different filters are there that can be manufactured with the help of these nanomaterials. Or different products can be manufactured and that can be used in the different industries. Now first is the nano enzymes. Okay, some nano enzymes can be okay, these second and third points you have to read it together. Okay, some nano enzymes are manufactured, and these enzymes can be used for performance of the different biological operations. Okay, different biological operations are there, like biosensing, bioimaging, or some tumor diagnosis can be done. Okay, or antibiofouling is there. These different different operations related to the healthcare, okay, related to the healthcare industry. In all these artificial enzymes can be used. Then it can be used for manufacturing of the paint. Okay, paint nanomaterials can be manufactured. Then why these are used? Because it will improve its UV protection or UV aging. Now you can, nowadays you can see the advertisements like these paints are Asian paints advertisement is there, means it does not get affected due to the environmental conditions like heavy rainfall is there, or suppose high temperatures, very high temperature summer is there. Due to that also that paint remains unaffected. Why it is so? Because of the presence of the nanoparticles in there. Okay, like that Asian paints they are using for the advertisement, the paint consists of the nanomaterials. They are using that advertisement. If you have seen, watched it on the TV, abhi to aur chalega, like that they have advertised their Asian paints. Okay, Asian paints they are advertising like that, means it does not have any effect of the different or worse environmental conditions also. Means it can sustain the heavy rainfalls, or it can sustain very high temperatures during the summer also, like that. It is due to the presence of the nanoparticles in that paint. Okay, then high quality filters. High quality filters can also be manufactured with the help of these nanoparticles. And where these filters are used, in your different water purifiers are there. Water purifiers are there. There you can use it. Now the water filters created by that Selden technology, this is one in firm, or you can say that one industry which is manufacturing the different water purifiers. They have used the uh, these nanoparticles. Okay, nanoparticles materials to manufacture the filters. Okay, so that it will remove that whichever viruses are there, that will get removed during the purification of that water. Then the you can, now these nanomaterials can also be used in the air purification field. Okay, now okay, there is one virus in the 2012, like whichever pandemic conditions right now we are facing due to the COVID-19, that same some one respiratory virus is there, that is the MERS, MERS. Okay, Middle East respiratory syndrome, its long term will be Middle East respiratory syndrome in the Saudi Arabia in 2012. For that for combating that the spread of this MERS, they have used the nanoparticles in the air purification system. Okay, then these nanomaterials can also be used for providing the insulation technologies. Okay, some insulation technologies can also be provided, or it can be used for provide that. Then it can be used as the lubricant additives. Nanomaterials they are having the ability to reduce the friction between the moving parts. That's why they can be used to means they can be used as the lubricant. Then nanomaterials can also be used as the you can say that three-way catalysts. Okay, three-way catalyst means for controlling the emissions of nitrogen oxides. uh, you can control the emission of that nitrogen oxide. Then for that you can use the nanomaterials only. Then different kinds of the shell structures are there that can also be manufactured. Core shell structures are there, can be manufactured with the help of these nanomaterials. And that core shell structures are used for protecting the noble metals like palladium, or you can say that rhodium, like that. For the protection of these noble metals, you can use a core structure shell. Okay, that will be made up of the nanomaterials only. In this way, these are the different applications. Okay, these are the different applications of the nanomaterials. These are the different types, or different, in short you can say that different types of shapes of the nanoparticles and their existence. in the different forms. Means you can say that they will exist in the form of tube, in the form of sphere, in the form of capsules, or they will be presence in the form of some self-assembled form, or in the form of some shell, okay, or in the form of some synthetic virus, okay, some synthetic virus like shape will be there. Okay, these are the nanoparticles. We have discussed now in this way. In this lecture we have discussed related to the composite materials and nanomaterials. In that we have discussed related to what you can say that their composition properties and their applications. Okay, in examination they will ask you only directly, they will ask you to write a short note on composite material or nanomaterial. Then first you have to explain what is the meaning of composite material or nanomaterial. And after that you can after explaining their meaning, you can write the some of their specific properties. Then if any type is present, like in composite material different types are there, that type you can mention. In nanomaterials, depending on their shapes or their existing different types, you can explain whichever diagram I have shown here, that types you can mention there. Or you can draw these diagrams also in the same way. For this composite materials, you can take these diagrams and you can explain their different types and their different, according to their composition, different types will be there. Then for each type you have to explain their particular properties, their particular properties, composition and applications in case of these composite materials. And in nanomaterial case, directly you can explain some general applications. Lots of applications are there. You will be able to write minimum 7 or 8 applications. Okay, it is widely used in the manufacturing of the paints. In short, in the healthcare industry, then paint industry, then filters which can be used in the sorry filters which can be used in the water purifiers or air purifiers. Then insulation, it can be used for the manufacturing of the different insulations. Then it can be used as lubricants, additives. Okay, then it can be also used for the protection purpose. Okay, it can be used for protection purpose, or it can be used for the TWC application, that is three-way catalyst. In that, with the help of this three-way catalyst, you can control the emissions. Okay, now in this way we have completed this part. Okay, we have completed in this lecture what we have completed: composites, materials and nanomaterials. Now in this way the third chapter is completed. A third chapter, total third, 3 chapters we have completed in this way, and this third chapter is also finished. In this way we have completed the first section. Okay, first section, introduction of the first is the introduction and phase diagram. You can say that introduction of the ferrous materials and phase diagrams. Then after that, the different ferrous materials and ferrous alloys, in that steels, cast irons, then different alloy steels along with the iron carbide equilibrium diagram we have completed. This is the third chapter, non-ferrous alloys, we have completed, along with the some composite materials and nanomaterial study. Okay, now in this way we have completed the 3 chapters. Thank you for attending this lecture. Wait for 1 minute. Thank you. Before that, I will stop this recording, and if you are having any questions, you can ask me. Thank you for attending this lecture.